So now we in our third segment, which is advanced variations, and we're going to go from left to right. So what we're going to be doing in this instance is we're going to go from function to problem to assess, diagnose, plan, intervene, evaluate, and create the structure. So going from left to right, as you know, is used for creating structures, forms, and variations to solve problems. So basically what we're doing at this point is we're going to jazz. We're going to get away from, we've kind of understood the scales with the basics, okay, going from right to left and identifying, clarifying what it does. Now we're going to play around with it, okay, and we're going to come up with a couple of things and just kind of try things on. All right, here we go. So let's look at our equation again. All right, so we're going to go this way with our equation, used for creating structures, forms, and variations to solve a life need problem. Well, what's our problem? Our problem is, in this instance, that, let's say, for example, our hand drill material is too fragile to use. So let's say I'm trying to spin down the stalk and the stalks just break. See how fragile this is? Look. Some examples are milkweed, cattails, lamb's quarters, very fragile stalk spindles. What would you do to remedy that situation if you needed to do a hand drill or mount drill, which we're going to go over later? And how can you spin down a stalk that's going to just keep breaking on you? How do we create a form that fulfills that function? What variables need to be balanced in order to do that? Well, through Dr. Humphrey's equation method, our main problem is stability. So how do we make a spindle shaft stable enough to spin down for a hand drill? Well, one of the things that you can do is replace most of the stalk spindle with some kind of harder wood, a harder density wood. And I'm going to show you a couple examples of that in what I call the reload system, which I'm going to do now. Okay. So the next thing we're going to go over is what I call the reload system. And in the primitive technology, wilderness skill culture, sometimes this is called a plug system. Sometimes it's called scarfing, but that's a particular kind of technique. But some of the reloads that you may see are these, and they come in many different kinds of shapes and varieties. The reload system is very useful because here's what can happen is you're doing your hand drill, and then what happens is your spindle just kind of breaks on you. It happened to me with this lamb's quarter, and another time with this piece of thistle. and I had it happen again with a piece of cattail, which I'll show you. But in order to solve that problem, you may just want to get yourself a shaft spindle that you know is not going to break on you, because basically what we're dealing with here is, if we look at our board, is our stability factor. If the spindle isn't stable, in order to withstand the pressures of your hands going up and down the spindle, and it just breaks on you, well, what good is that going to be? So in order to start out to practice doing the reload system, you might just want to get yourself some hardwood dowels. Now here I have a few examples. I have the 3/8. I have a few 3/8. The smallest I have is a 5/16, because if you get any thinner than that, then what happens is your hands start to rub together instead of you being able to spin the wood. And the largest one I have here is a 7/16. If you have really, really large hands, you may be able to get as far as a 1/2 inch, but you're gonna sacrifice rotations because the diameter is so large that you're not gonna get enough rotation, and therefore your speed is going to be a little slower. So I recommend at least these three sizes. I definitely recommend the 3/8, if anything. If you could find a 3/8 shaft in your hardware store, that would be great. Nice and solid. Usually it's a hardwood of some sort. Some of these are poplar, some of these are just unknown, but you could start with those. So let me show you some of the reloads that we have here. Now here I have one where the shaft is cut on an angle, and usually this is the one that's usually called scarfing. And you can take sometimes a primitive glue along with cordage or fiber and wrap this around, and you take a piece of spindle that you know works. Now you have to be very careful if you're going to be using the hollows, because they can tend to be very fragile when you're working with pieces this small. So sometimes a solid is usually better, like a yucca. So in this case you may want to practice with one of those, but if either way you can get it to work is good. So because what it has to do is line up and match, and the hollows may be too fragile for that. So you may want a solid on a solid, and then for surface area you can drill yourself a hole if necessary, okay, to reduce the surface area from a solid to a hollow. Okay, now here for example's sake, I usually tend to use hose clamps. They're quick, they're convenient, and I can change them out quickly, especially when I'm doing demonstrations. I can't really take the cordage off, wrap it, unwrap it. That takes too much time during a demonstration. So what I do is I just hook and unhook the hose clamps on and off. So if you could see the join section there. Okay. Another example is the box. Another example is the box, and I'm going to take these down for us here so you can see what they look like. And the box notch looks like this, where it's squared off instead of being on an angle, and it's joined together like that. And then what I'll do is I'll take the hose clamps, and then you could use one or two to join them together. Two kind of makes it a little more stable. And then what I'll do is I'll alternate where the screws are so that it's more balanced if I have two. If I have screws on one side, they're all on the same side. That can throw off the spin. At least this way it's balanced. So that's the box notch type. Here's another kind of box notch type, or it's kind of a variation of a dovetail where it's a squared off kind of fit. Here it's kind of rectangular. And now the only thing with this is that it can be rather difficult to carve, especially if you only have stone tools. Probably the easiest one to carve would be the scarfing one, which is on an angle, and join it that way. And surprisingly, the angled one is one of the most stable as well. And here's a classic dovetail type. Just remove that. And you can see this goes in, it's triangular, and fits in that way. It's a good fit, it stays in, even without the clamp. Put the clamp back on. And that's ready to go. Now here's another type Y where I used a piece of bamboo section, which of course is hollow. The bamboo has a nice thick wall, so it's very strong. And I attached the hardwood shaft, this 3/8 hardwood shaft, to the piece of bamboo. Okay. Now, this way I don't have to fit the plug right to the hardwood dowel. It will fit within the hollow of the bamboo. So I secured them both with hose clamps, and my plug is just my reload here is a piece of yucca, which just wedges itself in there nice and tight. And the hose clamp is very important that it's on there when you do that, because it keeps the bamboo from splitting, because the bamboo will split. So you have to be careful with that. And that's really strong in there. And I believe all of these reloads, as I call them, are all yucca tips. And the spindles are all hardwood dowels from hardware store. Here's a variation of what you could use instead of hardwood dowels. Is I went to the arts and crafts store, and these are paintbrush handles, and as you can see, they are somewhat tapered. The top is thinner than the base, which is thicker, and they're numbered in sizes, so you could see what they were. Okay, and you would attach these just like this on here. And the thing is that the diameter at the top is thinner, which means that if you're floating, you're getting much more rotation because your hands are spinning the spindle faster. So as your hands go down the spindle, it gets a little wider and your rotations will be less. It may be a little slower, but if you got good floating technique, you're going to get a lot of good rotation. So there's a variation of that. I'm going to show you one of my favorites. And if you go to the hardware store, you're going to find fiberglass markers for things like driveways. Okay, and these things are like 4 feet long, and these are cut, and they come in a bunch of colors. Usually they're brightly colored, because what you usually do these is you stick these in the side of your driveway or a walkway for when it's snowing and you have to plow and you have to mark the driveway so that you could find the edges of driveways and walkways for like when you shovel. And these things are really, really cheap. But what there are is they're super, super strong fiberglass rods. For example, here's one of the shafts. And a lot of times they come with these rubber tips, which is really nice. So, let's get one of these off. These fiberglass rods. And this one here is about 2.5 feet long. It's yellow. And here's one of the sections that was cut off from that. But these are practically indestructible to break. And they have a little bit of flex in them, but they'll splinter horribly before they actually break. And of course, fiberglass, you have to be careful with splinters that they don't get into your hand. That's really awful when they get into your skin. They itch like mad, and it could cause an infection. But if you don't scrape these, or if you don't run your hands along it where there's a splinter, you should be fine. It has a coating on it that kind of protects that. So I really like these fiberglass rods. And what I like to use them with is, and again, the primitive technologists or people that do more purist type wilderness skills is they may call this blasphemy. Here I have a white one, which is I think a little over 3/8 of an inch. This may be closer to 7/16. But the rest of these are 3/8. This orange one, these two yellow ones, and what I have on there, as you can obviously see, are ratchet extensions, which I've epoxied in there. Remember earlier I talked about epoxy using to attach things, and what I did was I squared off. If you could see, I squared off the edges, much like this squared edge here, to attach it to the extension. And then what I can do now is I take ratchet extensions, just like this one, and I put a plug right inside. And of course, when you buy ratchet kits for tightening bolts, nuts and bolts and things like that, they come in many different sizes. So now you have a whole bunch of ratchets that you could fit different size reloads in. And watch this. That's all I have to do to put that in there. And I'm ready to go for a demonstration or what have you, just for practicing or getting this. So, and these are all, what do these measure? Let's measure them. So these measure to be about 25-26 inches long, so a little over 2 feet. When I cut these were 2 feet. So when you add the extensions on, you get a little over 2 feet, which is a really good size. Run your hands down the shaft of those. Now, as a variation of that, here I have a solid steel rod. And I use the grind wheel to round off, smooth off the top where I could be floating. But then down at the bottom, what I've done is I took the grind wheel and I squared it off, much like the end of the ratchet extension. And what I can do with this is with this steel rod, let's just pop that right on there. And of course, you know that is going to be indestructible. But if you bend it and you put a curve in it, it may be pretty hard to straighten that back out again. But of course, it would take a lot of force to do that, and you wouldn't do that on purpose. You should be very careful. Some other examples of reloads that I have. Reload system is I have this nice piece of bamboo, but the shaft is too thin to actually be a spindle in itself. So with the bamboo, I put 4 splits in it, and I stop the splits with a hose clamp so the splits won't go any farther. So that makes it stable. Now, what I can do with this is be able to fit in a plug of yucca. It's right in there. Wedge that hose clamp back on there. And now I have a bamboo reload spindle shaft with a yucca, which I hollowed out just a little bit to be able to use. Now you're going to find this one pretty funny. My mother used to golf, and I took one of her old golf clubs, and I put a hardwood piece on the top to round off so that I could float at the top. And as you can see, it tapers down thicker to the bottom, but the golf club, as you know, is hollow shaft, and I just fit a plug of yucca right in there. So this is also about 2 feet long. Now here is a just regular branch, and it's actually of some sort of wood which I don't even know. I collected such a long time ago, and I did not identify it as I should have, but I drilled a hole in it, put a hollow in it, and then put splits in it. I stopped the splits with a hose clamp, but the hose clamp also at the same time holds the yucca plug in place. And these are the original reload system shafts. You just took a branch from a tree or something that was nice and straight that wasn't going to break, and then you can economically use pieces of short spindle for a hand drill when you can't find long spindle shafts, or you can they're too fragile to use as a long spindle. So that makes up for that. That makes an excellent technique and method. Here's another bamboo one, which is thicker than the other one, and as you can see, these splits go all the way up, far up the shaft, you know, about maybe 5-6 inches. The splits are stopped before the node here with a hose clamp, and here I have another plug spindle reload of yucca. So that one's also about 2 feet long. Here's another hardwood. Actually, this is a bamboo shaft with a bamboo hollow used for the plug system. So this one's made entirely of bamboo. Kind of looks like a hardwood, but it's actually a shaft of bamboo with a bamboo hollow. So this one's solid, as you can see, and this is hollow bamboo, and a plug would go right in there, held by the hose clamps. This is actually another bamboo chopstick. Here I have an extremely thin bamboo shaft, and this is probably the absolute thinnest that I would go. This is way smaller. I think it's smaller than a 5/16 definitely, but because anything thinner than that, it would get too fragile, and my hands would rub together instead of being able to transfer that energy to the spindle. So the bamboo, very thin, bamboo hollow shaft hose clamped to a piece of yucca. So I drilled a hole into both sides of the yucca, okay, and the shaft fit into the yucca on the bottom. That's hose clamped, and I turned the yucca into a hollow there. So the bamboo actually fits directly into the reload in this case. As you may have guessed, this is a aluminum arrow shaft, and it's actually one of my old arrows off my my bow and arrow, which I'm not using anymore. And of course the aluminum shafts are hollow, and what I did was I fit it with a lot of times the ratchet sets come with an automatic reload system. So I put the reload system into the shaft, and now what I'll take is these adapters that fit into the reloads, like for screwdrivers and things like that. Some screwdrivers nowadays have these reloaded adapting parts. So this fits into the adapter there, and then I fit my ratchet plug onto there. So I can adjust this whenever I need to with a small reload of yucca on the end of that. And it's very light too to carry. Now this black fiberglass one is one of my favorites, and what it actually is a tent pole. So this was a one of 3 or 4 sections that are of course joined together with the elastic string that joins them so that they can go together. And here I have another plug of yucca that just fits right inside the hollow part of the tent pole, where the other fiberglass rod would normally join in there, connected by an elastic. Now the last one I'll show you is another one of my favorites, and it is a fishing rod shaft. Now I rounded the end off here so that fiberglass wouldn't get in my hands, and anything that would stick out that my hands would run along, kind of smooth down a little bit. But as you know, their fiberglass fishing rods are hollow, and here I just hose clamped another piece of yucca inside the fishing rod. So that's the reload system. And what I have here are some of those adapters that fit into like a screwdriver pieces, and then in here you would fit the extension adapters that go for ratchet sets that go in there. Now if you have something that's already hollow, like the arrow shaft or a fishing rod or a tent pole, that would fit in there. You'd epoxy that there, and then you could fit these in anytime you want to. And then these adapters, which you can get, they're super cheap. They're just like $2 maybe, and you can buy a whole lot of them, and you can get them in all different sizes too. So here I have a 1/4 inch and a 3/8 inch, and this cost me $2. So, and you can get a whole bunch of them. Here. Here's a long extension one. Okay. And no, they're not primitive. They're not purists, but it's a fun variation because we're jazzing away from the scales in the hand drill technique, as well as all the other techniques. And here's a couple examples of some reloads that I have. These are dog vane. Now what happens is your shafts are sometimes either too crooked or they're just not straight enough, and you have these smaller pieces. Well, you could use those for reloads when they can't be used as a spindle for your hand drill. These ones are yucca that I have, and you would just carve them and shape them down to fit as needed. And the thing about yuccas is they grow pretty crooked, so you may not get straight ones that are long enough for like bow drill spindles or hand drill spindles, but you could definitely have enough for reloads. If you have a even a crooked yucca shaft stalk, you're going to have tons of reloads, if anything. Now milkweed could make a really good hand drill, but like I said, once it splits, it doesn't work very well for a hand drill because it'll just keep splitting on you with your hand pressure. But they do make excellent reloads. Now the thing is that they're usually not perfectly round. They are kind of square in diameter. Their diameter is square, so you have to be really careful when you're working with these. Although they do work very well. Milkweed reloads. Here's some lettuce reloads. I got plenty of bow drill and hand drill spindles from some wild lettuce, and that's just what's left over. Evening primrose, I got tons of hand drill and bow drill spindles from those, but I had a few small straight short sections that I couldn't do anything with, but I could use them for reloads. And cocklebur is another one that's pretty good for hand drill, but during the winter I couldn't find one that was straight enough and long enough for a hand drill, but I was able to find and use one stalk for reloads. And there we go. And now I'm going to show you an example of my reloads, see them in action. Okay? Here's one of the box notch spindles. Bamboo attachment spindle. Steel shafts. 10 pole. Fishing rod. Fishing rod. Arrow shaft. Arrow shaft. Golf club. All reload system. So when you're doing reloads, the hollows can be pretty much tricky business. Milkweeds, I found to use as a hand drill, they really are too fragile. When I do my inward pressure for the stalk, they really just kind of break apart, and I've never been able to really keep one together long enough to be able to finish a milkweed hand drill that's whole. But I will cut them up and use them for reloads, and they are a true hollow, as you can see. They make one of the best cordages too. The outer bark of the plant makes really good fiber, as you can see here. This stuff peeling off right here. Another good plant for a hand drill is cocklebur. Here I have a couple of reloads. Cocklebur 2 is also a true hollow with a lumen, and what I've done here is I've scraped off the outer bark so that doesn't interfere with the spinning on the base, and where I have the bark left on, I'm going to attach it to a hardwood spindle. Actually, I've taken one of the bamboo chopsticks and I've shouldered it, as you can see here, and what that does is that'll fit right into the lumen, and in order to hold that in place, you can either glue it and use fiber, or in my case with demonstrations, I just use a hose clamp. So we're gonna attach that. So we're going to clamp that down very gently. Now that's attached. The reload is now attached to the bamboo spindle. Okay, so now I have stability in the spindle with the about 2-inch reload tip of cocklebur here. And I have a board of Douglas fir, which we're just going to kind of spin it in just for as a demonstration here. close up there. And that seems to be stable and working rather nicely. And we got to break through that glaze. You can hear it. You can see it smoking a little bit. And you can see some of the fiber starting to come off, but that's okay. It didn't destroy the coal at this point. So, but and that's how I came up with attaching this particular kind of reload to a hardwood stalk. In this case, shouldered bamboo to fit through the lumen. Give it a shot. Okay, so in this instance, when you're gathering natural materials, you're going to have a lot of variation. You're going to have a lot of variables. For example, in your bases and your notches, no matter where you go, whatever ecosystem you're in, they're always going to be a little different, depending on what you come across and how you're going to have to manipulate those things in order to make them work and function. What forms are you going to have to be able to make and create to make that work? Well, your notch, your containment and your notch has to be able to be just right. Your bases have to be stable, okay? And there has to be enough surface area in order to make it work. Also, the other thing you have to keep in mind is the height of your notch, because the notch needs to fill or already be filled, key component, as high as possible, because otherwise the coal won't form till the notch is full. Remember, we have to keep that in mind as well. So when we're creating, because we're going in this direction, the equation goes this way: used for creating structures, forms, variations to solve problems. We have to know what the function is, balance the variables, and create the form, whatever that's going to be. So, what variations, what form and structural differences can come about that are functioning for good bases and notches? Let's take a look at some variations. So the next thing we'll be going over is bases and notch variations. So usually, most of the time, your base is going to be some form of branch. For example, this sassafras, which is fairly hard and fairly tough. This one is for a bow drill, actually. We have a piece of sycamore here, and a old piece of willow, I believe. But these are old branches, and they've been kind of flattened out for stability, so you can rest your foot on it on some point. But the what you'll usually find, of course, is most branches are just round, and you just need to actually be able to just find a place to start your spindle to mate with the base. So here I started on this the bamboo chopstick. Now I carved down another bamboo chopstick just for it to be able to fit this. Now the qualifications for a base is that it has to be able to have enough surface area to mate with the spindle, and it has to have enough stability where it's not going to break on you. And and it also needs to be able to, you have to figure out a way to make it stay still as you're doing your method and your technique. Now this is actually a yucca stalk, and one side has been flattened to be able to mate with other yucca stalks. Right? It's usually some form of a branch, which you will manipulate in order to make it stable and make sure it has the right amount of surface area to be able to receive the mating process of the spindle. So the next thing I'm going to show you though is the Y stick branch and notch variation. Now, as you can see, the Y allows it to be able to form its own notch, but it's not going to be as perfect as that. So you're either going to take your stone tool or your knife or your file or something like that, and you're going to have to, after you figure out a way to mate it just where it needs to be in this surface area of where the three places join, you're going to have to adjust your notch to make sure that it is just off center, so that it doesn't drill into the notch. And so it would start off looking like this piece of willow here, this willow Y branch, and you may need to figure out how to flatten it or just be able to make it more stable as it sits on the ground. But then you'll either apply whatever method is that you're going to do, whether it's hand drill, at least like we're talking about in this case, or mount drill or bow drill, and you're going to get a coal in the notch of the Y. There we go, like this one did before. I'll show you the pictures for that. Another method is the two-stick method. So let's say you don't have a branch that it has the surface area or is wide enough to be able to receive a spindle. The spindle is actually too large for the base. Well, if you have two nice straight branches, so like take this example, I have two small pieces of yucca that are really short that I can't really do anything with spindle wise, but the two of them together matched up can be able to make a base for a spindle now that I put the two of them together. And works in that fashion. And I'll show you a picture of that, how that works. Another example is the trench or the trough method. And sometimes in nature, you're going to find a place where there's a groove naturally occurring in a branch or somewhere in the wood. And that can be used as a notch. Now you only have to be careful that you don't burn past the trench or the trough and you go below it, because then the powder won't have anywhere to go. So if the trough or the trench is pretty deep, for example, when you are doing your regular standard notch, it has to go clean through the wood, right? The walls have to be parallel, straight up and down, and go clean through. The only difference is the trough does not. But a warning, it must be deep enough that if you start drilling down, and you will be drilling down into the wood, it's only natural, that you don't drill past the trough or the trench. Okay. So sometimes that's usually only good for one shot. a lot of times. But a notch is much better than a trench or a trough, in my opinion. So, another example of a different kind of base or notch method is the multiple holes. Sometimes it's called consecutive holes or consecutive pits. And in this case, I just happened to start one with a drill hole, just as an example. And then I started drilling next to it, and this is done with a solid bow drill, just as an example. And so I picked this one because it's large enough for you to see. And as you can see, the circumference of that circle enters the circumference of the circle next to it. And what happens is that acts like a notch, and the coal forms in the first notch is what happens. And then what you do is you just keep using holes as a notch as you go down and make new ones. So we had a coal form in this one, and then if I were to make a hole here and mate a spindle there, this one would now be the notch. Another example of different kinds of bases is, instead of actually using wood, for example, your branches, there is also another option of there being two kinds of funguses. There's your like shell fungus, your polypore shell fungus, which grows off the sides of trees, sometimes called conchs or artist's funguses. There's many, and these are just a few examples. But these, when they're dried out, they make excellent fireboards as well, bases. So here I got a coal on the first try with this piece of polypore right off the bat there. And another one you can use is something called tinder fungus. And here again, on my first try, I got a coal from this piece of tinder fungus used as a base. Very flammable, these things, and if you will recall, these when you powder them are used for coal extender, make excellent coal extender. And the thing is that once you have to be careful, is that once you get your coal in your notches here with your polypore and your tinder fungus, is that your whole base is going to start catching and become a giant coal, because since these are coal extenders, they just coal up themselves. So the coal being in the notch, this whole base is going to end up being a giant coal if you're not careful. So when you go to put this away, make sure that the whole thing is out. And there you go. Some notch and some base variations to choose from. So here is a close-up example of using a spindle-like branch for a base board. And here I have written that on May 12th I used a bamboo spindle on this bamboo chopstick. And obviously the spindle was a little thinner in diameter than using this 3/8 inch chopstick. So obviously the spindle was less than 3/8, and I just barely had enough surface area on this 3/8 chopstick to make that work, obviously. And you can see the burn marks around the notch that is made. As you can see, this is completely round here. A lot of times in Australia, the Aborigines there, when they do their hand drill, their technique is somewhat like this, where the base is actually just another branch. So just to show that off. Now another good thing to mention is the stalk on stalk method. And what I mean by that is, for example, this piece of yucca, which you can see here, this is the top, and there's still flower on here from when it was alive, all the little branches. So this is the top of the stalk, and as we get near the bottom, near the base, obviously it gets thicker. So basically what you have here is, if the top is thin enough, that could be a spindle in there, and as you get near the bottom down here, this could be your base. So let's say, for example, we cut here, and that's our base, and then we go all the way up here, and this is thin enough, and we cut that, and that's our spindle. Well, here I happen to have a yucca, and as you can see, they have the insect holes in it from when they emerge. Now here I have a really thick base, and this would be closer to the top of the stalk, and we're just going to say that these came from the same stalk, although I really don't think they did. But you can see the difference in the size, and you get the idea of what I'm talking about. So what we're going to do is we're going to stabilize this base with our clamp. Okay. I'll back this up here. Get a little closer. And we're gonna start spinning inside our base. You see we're getting some dust. Okay, and that's how you would do your spindle on a base from the same stalk. Okay, just use the larger, thicker base with the thinner top portion of the stalk itself. Okay. So here I'm going to try a multiple hole example. Now here in this Atlantic white cedar, I already have one deep hole made by multiple use of getting a coal in this notch. Now I've marked this one here to start mating for a new hole here. So now I'm going to take out a little bit of the wood, because this piece of bamboo is a hollow, so I can't use the pointed method as I would with a solid spindle. So we're going to remove that piece of wood. See if we can't start its mating. starting to fill nicely. And I think we got it. Yes, we do. So this is the new hole here. New hole here. This is the old hole. And that old hole made our new notch, which there is a coal in now. So let's remove that. So I could show you both examples here. And there we go. Here is the new, let's pop that button out. Here is the new hole. Here is the old hole, which created the notch. New hole, old hole, and the coal, which formed in the notch, which is the old hole.